Question 25 is actually pretty challenging, and it's pretty challenging because they're making it a little bit more confusing than it needs to be. And so we're given this information. They're asked, what is the ratio of ammonium chloride to ammonia in order to make an ammonium chloride buffered solution? And so one of the challenges already is they've given us this ratio in the opposite of how it would show up in the calculation or in our Henderson-Hasselbalch equation, because they've given us acid over base. When normally in the Henderson-Hasselbalch equation, pH equals the pKa plus the log of base over acid. And then they give us this pH information and the Kb. So there's two different ways we can solve this. And again, it's kind of odd in how they give us this information, especially giving us pH and giving us Kb, giving us conflicting information. Because, yeah, in the Henderson-Hasselbalch, I need pH, but I don't need Kb, I need Ka. So, okay, I can go find Ka to do that. Or I can go use the other version of the Henderson-Hasselbalch equation. POH equals pKb plus the log of acid over the base. And so I'm going to do this calculation both ways. Before I get started, please pay attention to your pH. pH is a variable here, so that will be different for everyone doing this problem. So to attempt this calculation the first way, using POH and the Kb, right, I know with a pH of 8.5, I know pH plus POH equals 14. So I know the POH of this solution is 14 minus 8.5. The POH is 5.50. So, okay, I've got a POH of 5.50. That equals the pKb. So pKb is negative log of Kb, 1.8 e to the negative 5, plus the log of my acid over my base concentration. So I've got 5.50 equals the negative log of 1.8 e to the negative 5 is 4.74 plus the log of acid over base. Subtract 4.74 from both sides. And I get 0.755 equals the log of my acid divided by the log of my base. And so, to get rid of this, right, I need this ratio. That's what I'm asked to find, is what is the ratio of acid to base, right, when I have this pH of solution. So what I can do is I can raise, right, I can take 10 and raise both sides. So 10 to the 0.755 equals 10 to the log of my acid over my base, and that will get rid of the log function. So 10 to the 0.755 gives me 5.7, right? And that equals the ratio of my acid to base. And that's what I'm asked for. I'm asked for what is that ratio. And if you weren't sure, if we were unsure about this, we could just take that and plug that back into our calculation and make sure that this worked, right? So if I go back and plug this into my calculation, I get 5.5 equals the negative log of my Kb, 4.74, plus the log of, I don't know these concentrations, but I do know the ratio is 5.7. So I get 5.5 equals 4.74 plus the log of 5.7. The log of 5.7 is 0.755. Add those two together, and I get 5.50 equals 5.50. So that works. That makes sense. That checks out. And that's using POH equals the pKb plus the log of acid over base. That's what they were looking for. The other way we could answer this calculation is using the traditional Henderson-Hasselbalch equation where pH equals the pKa plus the log of the concentration of base over acid. Right, we know pH is 8.50. pKa is the negative log of Ka, right? And I can find the Ka because I know Ka times Kb equals Kw, right? Kw being 1e to the negative 14. So that makes my Ka for ammonia, right, would be 5.6 e to the negative 10. So 5.6 e to the negative 10 plus the log of my base concentration over my acid. Okay, 8.5 equals the negative log of that is 9.25 plus the log of base over acid. Again, I'm going to subtract that across. I subtract that across. And I get 0.7, I get a negative 0.75 equals the log of my base over my acid concentration. Again, to get rid of the log function, right, I'm going to raise both sides to that value. So 10 to the negative 0.75 equals 10 to the log of base over acid. Right, so 10 to the negative 7.5 gives me about 0.176, and that equals the concentration of my base over my concentration of my acid. So if you did it this way, and I understand why you would do it this way because they gave you pH, right? If you did it this way, you've found the inverse of what they're asking, because they're asking for what is the ratio of ammonium chloride to ammonia, and that's acid over base. We found base over acid. So if this question wasn't tricky enough, right, we've got one more step. I need to take the inverse of that, so 0.176, right, 1 divided by 0.176. And I get that ratio of acid to base equals 5.7. So in both cases, right, we got the same answer, 5.7, and it should be to 1 decimal place, right, 2 significant figures total in this calculation. So again, a very tricky question because we had to do quite a bit of legwork to get to the final answer, and the slight problem of also algebraically, how do we get rid of that log function to find out what this ratio is? At the end of the day, because it was quite a bit of calculating, I would always recommend of going back and checking your work to make sure, right, does that number that I found check out?